The simplest expression we have in our language is a prefix expression, where we have an operator followed by an expression. We also treated a lot of language constructs in our parser as prefix expressions. Right now, we are only going to deal with expressions that actually have our two operators preceding them, the not operator and the minus sign. We are also about to define some key behavior in our parser. What if we put not 5, or not true? The evaluation step is where we really define what is legal and the personality of our language. In our case, anything with a value, like 5, is truthy, so saying not 5 would return false, and not true would be two negations, and we like how that sounds, so it will return true. Let's go back to our evaluation method and add another case for our prefix expression nodes. In the body, we are first going to evaluate everything to the right of our operator. So we are going to recurse down and call eval on the right side of our node, which is stored in our value field. Then we are going to call a helper method called eval prefix expression that we will write in just a moment. Our helper method here is going to take a string as the first parameter, which will be our operator. The next parameter will be an object that represents the right side, and we will of course return an object. Inside of the method, we are going to do another switch statement depending on the operator. First, create a case for our not operator to start out. In the body, we will call another method, evaluate not operator expression, and pass in the right side. Add a default case that will return our nifty null object that we created in the last episode. Our helper method will take an object as a parameter and return an object. The nice thing is that the not operator expression can only return a true or a false value. So let's create a switch statement and go over the basic case of true, false, null, and the default case. That, my friends, is how we handle the not operator. Now let's go for the negate operator or the minus sign. Start by adding another case to the evaluate prefix expression switch statement. And let's follow the pattern we established, and in the body call a helper method called evaluate minus prefix expression. And the helper method is really straightforward. We accept an object as a parameter, and we return one when we're done. And in the body, first things first, we only expect to see this operator prefixing integer objects. So let's check that real quick. Second, we pull the value out of the right side object. Lastly, we just want to return a new integer object with the value negated from the original object. And with that, our prefix expressions are done. Now let's turn our attention to the infix expressions. We really have two types of infix expressions, those like 5 less than 10, which produce a Boolean result, and those that don't, like 5 plus 10. We are going to start with the second type. Like everything else, let's go ahead and start by adding a switch case to our evaluator method. In the body, we are going to evaluate the left and right sides separately. Then, we are going to call a helper method called evaluate infix expression. This follows the pattern that we have set with the other evaluation flows. Now let's get started on the evaluate infix expression method. It takes 3 arguments, a left side object, a right side object, and an operator to apply to them. It will also return an object. In the body, we are going to open up, surprise, a switch statement. Phrase of the day while coding an evaluator is switch slapped. For the first case of this switch statement, let's just check if the left and right sides are integers. Then in the body, call a helper method called evaluate integer infix expression that we will code in just a moment. And for the default case, let's just return the null reference. The helper function evaluate integer infix expression is simple and is going to have the same signature as the previous function. In the body, the first thing that we are going to do is cast the types and extract the values of the left and right side objects. After all of this, all we are going to do is switch on the operator for each arithmetic operation and return an object containing the result. Of course, in the default case, just return a null object. And we're finished. Let's go ahead and test drive our new functions in our console. We can go ahead and test out our not operator, minus operator, and arithmetic operations. And with that, we have made the most kick-ass calculator in existence. In the next video, we will hit up our Boolean infix expressions and add support for conditional statements. See you there.